Let us discuss in detail about a disaccharide, sucrose. Sucrose is nothing but the cane sugar. As we have discussed, sucrose is the popular example of a non-reducing disaccharide. Let us see some information about the sucrose. On hydrolysis of this disaccharide, sucrose, we get 2 units of glucose and fructose. Both are the D designations. Glucose as well as fructose, they are the monomeric units for the disaccharide, which is called as the sucrose. You can see the reaction, that is hydrolysis reaction of sucrose, which is giving you D glucose and D fructose. You can see the hydrolysis reaction of the sucrose, which is giving you glucose and fructose as the monomeric units, that is hydrolyzed products. Likewise, other disaccharide units, sucrose is also having a type of linkage which is called as the glycosidic linkage. In the structure on the slide you can see the disaccharide, it is having a glycosidic linkage between the carbon number 1 of alpha D glucose and carbon number 2 of beta D fructose. We know glucose is the aldehydic functional group, that is, it is an aldoses, whereas fructose, it is ketose. Therefore, in case of glucose, the anomeric carbon is carbon number 1. In case of fructose, the anomeric carbon is carbon number 2. The linkage between carbon number 1 of glucose and carbon number 2 of fructose, it is called as the glycosidic linkage of the sucrose. The second disaccharide is maltose. It is also called as malt sugar. Let us see the structure of maltose. You can see in case of maltose, the monosaccharide units are alpha D glucose and alpha D glucose only. That is, it is the monomer of the disaccharide maltose. Let us see the glycosidic linkage present in maltose. You can see in this case, I am highlighting the carbon number 1, that is anomeric carbon of first glucose unit. It is involved in the glycosidic linkage. And the another glucose unit in which the carbon number 4 is involved in the glycosidic unit. Therefore, the linkage present in maltose is glycosidic C1-C4 linkage. That indicates the anomeric carbon, that is carbon number 1 of the second glucose unit, is free. That means, that is the reason this sugar maltose, it is called as the reducing sugar, because after opening of the cyclic pyranose ring, it can give the free aldehydic group which will act as the reducing sugar. The second disaccharide unit is lactose. As we know, lactose is present in milk, therefore it is called as the milk sugar. The structure of lactose we can see on this slide. It is having 2 units, and the 2 units are, the first one is beta D galactose and the second one is beta D glucose. Let us see the structure in which glycosidic bond I am highlighting. You can see beta D galactose, of which carbon number 1, that is anomeric carbon, is involved in the glycosidic linkage. Whereas you can see the second unit, glucose, in which carbon number 4 is involved in the glycosidic linkage. That means the anomeric carbon, that is carbon number 1 of glucose unit, is totally free. That is the reason lactose is also called as the reducing sugar. Let us see one simple question based on this. The question is, which is the non-reducing sugar? As we know, out of the given options, sucrose is the popular example of non-reducing sugar. We have already seen the structure of sucrose. In the sucrose, the anomeric carbon atoms are involved in the glycosidic linkage formation. That is the reason it cannot act as the reducing sugar, and hence sucrose is the example of non-reducing sugar.